For the last 15 years, the standard way we use computers has forced everyday users to do most of the work. If you wanted to book a flight, update a database, or fix a bug, you had to open each app, move through every screen, and click every button yourself. You were the driver, and the software was just a set of controls. But now we are moving toward a different model. Instead of doing every step manually, you simply give the AI a goal. Rather than clicking through menus, you explain what you want done. Schedule a meeting with the board, improve performance, update the customer record, and the AI agent handles the software for you. This changes the interaction from manual work to goal-based delegation. On the left, we see the old way, a tangled web of manual steps. On the right, the agent takes one clear command from the user and moves through email, calendar, and CRM tools to complete the task. For this to work, AI has to move beyond being just a passive helper. It can't only draft emails or suggest code edits. To be useful at a larger scale, AI needs to become something that can actually take action. It needs to become an agent system that can start tasks, complete transactions, and carry out full workflows on your behalf. As AI moves from suggesting actions to actually doing them, the big question changes. It is no longer just, should we use AI? Now it becomes, how do we control what authority we are giving to these systems? Today, AI agents interact with software in two main ways. Some run inside secure cloud browsers, which are useful for things like filling out forms. Others can control a computer screen directly by looking at screenshots, understanding what is on the screen, and figuring out where to click. But even the smartest AI model is not very useful if it falls apart when it touches real business systems. There's a big difference between an AI knowing what to do and an AI being stable enough to actually do the work. In a business setting, three problems usually break basic AI agents. First, delays can make repeated tasks slow and expensive. Second, when an app's design changes, the agent can get confused and fail. Third, agents can struggle to keep track of information across several different tools. The AI model is the brain, but the brain still needs hands, memory, and guardrails. To move from an impressive demo to a real working system, businesses need a dedicated execution layer that handles actions safely. A reliable execution layer has to work where the actual work happens. That means moving beyond simple web apps. It needs to work inside normal operating systems, older virtual desktop systems like Citrix, and secure testing environments where company data stays protected. If every AI model needs a custom connection to every business tool, things quickly become messy and impossible to scale. This is where the Model Context Protocol, or MCP, comes in. MCP acts like a nervous system. It helps connect AI models to tools like CRMs, databases, and business apps through one shared standard. Creating standard ways for agents to connect to tools and data is how we move from fragile prototypes to dependable business infrastructure. But giving AI more freedom also creates new risks. One example is called the confused deputy problem. In simple terms, this happens when a bad instruction gets passed into a low-level agent, like an email sorter. That agent could then trick a more trusted agent, like a purchasing agent, into doing something it should not do, such as approving an unauthorized payment. Traditional software security is not always designed to catch these prompt-based attacks. Because agents can take action on behalf of a user, we need to protect them with the same seriousness that we use to protect core computer systems. That means setting strict boundaries around what they can and cannot do. The untrusted AI model needs to be surrounded by layers of protection. Sandboxing can limit where it operates. Interface filters can block connections it should not have, and role-based permissions can control what the agent is allowed to change. You cannot have real autonomy without a strong safety system. The system has to assume that the AI might eventually be tricked or make a mistake, and when that happens, the damage has to be contained. As these systems become more reliable, human oversight will also change. Instead of a human approving every single step before it happens, we move toward a model where humans supervise the system while it works. The human is still in control, but they are watching from above and stepping in only when needed. This kind of supervision is built in layers. At the model level, there can be safety filters that help catch risky behavior. At the company level, there can be policies that control what agents are allowed to do. And outside the company, there can be monitoring, reviews, and third-party audits. But all of this depends on strong audit trails. If a company is going to give authority to an AI agent, it needs to know exactly what happened, who approved the agent, what data did it access, what actions did it take, and who is responsible if something goes wrong. Without clear records and clear human accountability, businesses will not hand over their most important workflows to AI agents. Trust requires receipts. This is the full enterprise agent stack: a reasoning brain, a standard nervous system for connecting to tools, reliable digital hands that can take action, a safety system that protects against mistakes and attacks, and a human overseer who manages the whole process. Apps will not disappear in this new model, but they may move into the background. Instead of people opening and using every app directly, AI agents may operate those apps for us. The advantage will no longer belong only to companies that build software. It will belong to the companies that build the infrastructure to manage, control, and trust the agents that operate that software.